Hello everyone, so in today's video I'm going to be taking a look inside this 12 volt air solenoid valve, and I'm also going to suggest some modifications which can be made to it to improve its performance, because I intend to use this in a air gun project. So the first thing you need to do is just remove the nut from the top here, and the washer and the plate here. This comes off, and that's the coil, and then you just have this part like this, so that unscrews. You'd normally use just long nose pliers to unscrew this, or maybe another suitable tool. So inside the body here, the air comes in through this port here. Now, a modification you can make to the valve is to file that wider, make it larger, and the force, the pressure of that air, as well as a small amount of force from this spring, actually pushes this plunger down. It normally forces it down, and this rubber seal is forced against this hole, and that's where the air comes out. So a modification I made to this was I actually drilled that out a bit wider, made it a bit larger, until the hole itself, like that, you can see there's maybe a sort of a flat shelf around there. I actually filed it, well, drilled it out so large that that flat shelf was gone, and then I refiled the whole thing flat. I think I used some sort of Dremel stone just to make that flat again. So there's a much larger hole for the air to come out again. And for at least an electronically triggered air gun, this is probably one of the best valve designs to use. I've successfully ran this at 200 psi, and I think it could probably withstand much more. It says in its design it's rated for 100, I think it's about 120, 140 psi, something like that. And if you were to put, and the problem I had was when I started running higher pressures through it, it would not open, because the pressure of the air pushing this metal plunger down was just too much for the magnet to overcome. So I actually had to run 40 volts into that normally 12 volt coil to get it to open. But the thing is, you're only doing that for an instant, very, very quick instant, so the coil cannot overheat, and it just pulls this open quick enough to fire a projectile down the barrel. So probably what you could do, rather than going into step-up electronics to try and trigger this, you could just either 3D print another bobbin, or take the wire off this and wind it with fewer turns of much thicker wire, and then run 12 volts to it, and then you'll get a lot more current going through it. And probably use a MOSFET to actually trigger it. A sort of a MOSFET as a switch, so that would probably work quite well. Just now what I'm doing is just a simple button, and that's got 40 volts running through it, and I've actually got another one of these valves, and just like you do with a relay, I just put a diode across the coil just to suppress the spark so it doesn't destroy the contacts in the switch. So that's really the only modifications you need to make to this. The barrel that I'm using on my airgun project is 10.5mm caliber, and it fires 3D printed bullets, little plastic things. It's basically just like a very powerful Nerf gun, something sort of like this that it fires. Very light, not even as much power as a small air rifle. So it's not particularly harmful. It's just more for fun. But I reckon if you somehow managed to mould these out of lead, you'd have something which could do quite a bit of damage. But that's up to you. There are other types of valves that you get which you would probably try and use, which have bigger openings on them than this. This is a 1/4 BSP pipe thread, British standard pipe, and you get ones that are a 1/2 BSP and 3/4 BSP. But the problem with those valves is they use a totally different design. It's got 4 bolts on it and it's just got a diaphragm inside, that rubber diaphragm, and I'm concerned that under 200 psi that could rupture, or the whole valve could just blow apart. On this valve, the only part that could really blow apart under very high pressure, if you're probably taking up to about 800 psi, I reckon, is this part here could maybe blow off the top of the valve. That's what I'm concerned about. So what I'm going to do is maybe some pressure testing, because it looks like it's just sort of crimped on. Maybe what I could do is, if this material will solder, I could probably run solder in there and that could withstand much higher pressure. But then I'll be looking at using some very thick wire on this and probably high voltage to trigger it. I might need to rewind this with thick wire and then trigger it probably with 60 volts as well, so I'll need to do more testing in that regard.